Hey friends, I'm here with the solution of the question that were given in the previous video. So let's go through the questions fastly. This was the first question that was given. 1 by log x to the base p by q plus 1 by log x to the base q by r, 1 by log x to the base r by p. We can see here that we have got x and we should try to get this x as the base so that we can get a common base and we can solve this question. So let's solve this question. As said, we need to use this base changing formula so that we can get this x as the base. So using that formula, we got log p by q to the base x plus log q by r to the base x and log r by p to the base x. Now, since all the bases, since we have got the common bases, we can apply the logarithmic properties and using the log property, that is log x, and we multiply all the three, p by q into q by r into r by p, and we can cancel each one of them, p by p, q by q, r by r, and we got log 1 to the base x, and we always know that log 1 is equal to 0, and this can be verified if you want to prove this, that x to the base 0 is equal to 1. So log 1 is equal to 0. Log 1 is equal to 0. So the answer for this video or this solution is 0. Now going to the next question. The second question was 1 by log bc to the base a plus 1, 1 by log ca to the base b plus 1, 1 by log ab to the base c plus 1. We can see this 1 is an odd value that is not present in the logarithmic form. So we should make sure that it can be written in the log form. So since we have got a as a base here, b as a base here, so we'll write this 1 in the logarithmic form using the a as the base. So I've rewritten the above equation as log bc to the base a plus log a to the base a, since we have got log a as the base here. Similarly, for the second part, log ca to the base b plus log b to the b, since we have got base b here. And for the third part, 1 by log ab to the base c plus log c to the base c, since we have got c as a base here. Now we can see that we have got common bases in the previous part, so we can apply logarithmic property, and having the same bases, having addition in between, we can multiply both the values. So using that property, log abc to the base a, for the second part 1 by log abc to the base b and log abc to the base c. Now I am using the base changing formula again, that is log a by b. It can be written as 1 upon log b to the base a. So I can change the base whenever I want just by taking the reciprocal and changing the base. So using that, since it's in a reciprocal, we can easily convert the above equation and get the ABC as the base, common base for all the three parts. Now log a to the base ABC, log b to the base ABC, log c to the base ABC. Now we have got this, and since we have got common base, we can write this as log ABC to the base ABC. How do we get this? Because we have got common base, we have got addition in between, we can apply the formula. What was the formula that we are using here? Log a x plus log a y. This can be written as log xy to the base a. So we can multiply it. Similarly, ABC gets multiplied, and the final answer, final computer value for this will be log ABC to the base ABC, which will finally result in 1. Okay, this is the third question that we are solving. The question here is log 7 to the base 10 is given as a, and we need to compute the value for log 1 by 70 to the base 10. In this type of question, we mainly focus on the right hand side, or the value that we need to find. So let's write this log 1 by 70 to the base 10. We can write this in this form, that is log 1 to the base 10 minus log 70 to the base 10. this can be written as this can be written due to the formula, or using this formula, log a by b is equal to log a minus log b. Now, looking at this equation and this property that I'm thinking of using it, log b to the base a plus log c to the base a, but we have got a plus sign, and in the above equation we have got minus sign. So what I'm going to do is to take minus as common in this part, and I'll rewrite the same equation as minus log 1 to the base 10 plus log 70 to the base 10. Now I can apply the above formula, that is log BC. So using that, what I can write, that minus remain as it is, that is log 7, it will be log 70, right? Log 70 to the base 10. So instead of writing log 70 to the base 10, since, why I'm not writing that? Because we have already got the value of log 7 to the base 10. So I'm just trying to use that value, and instead of writing 70 directly, I'm writing log 7 into 10 to the base 10. And now I'm again expanding this, keeping minus as it is, log 7 to the base 10, since it's multiplication and we are applying log on both. So see, I'm just reversing this formula. Log BC to the base A can be written as log B to the base A plus log C to the base A. Similarly, here we can what we can do, I can write log 7 to the base 10, since it's multiply, so vice versa using the formula, it will be log 7 to the base 10 plus log 10 to the base 10. Now we need, we already know the value of log 7 to the base 10, so it will be a, and the log 10 to the base 10 is always 1, we already know that. So the final answer to this question will be minus a plus minus whole bracket a plus 1, or it can be either also written as minus a minus 1. So it can be either this or this, as the option is given. So let's go to the next question that we have. We have got log x to the base 4 plus log x to the base 2 is equal to 6. We need to find the value of x. Now I can write this as log x by log 4 plus log x by log 2 is equal to 6. Log x by log 4 can be written as 2 square, and this power 2 will come this side, right? Because we already know this, so I'm writing it straight away, plus log x by log 2 is equal to 6. Now, log, I am taking the LCM, that is log 2 log 2 will be the LCM. So taking the LCM is log x plus 2 log x is equal to 6. I took the LCM 2 log 2 in the above equation. So the final answer computing will be 3 log x upon 2 log 2 is equal to 6. So it will be, now the answer, the equation that we can get is 3 log x is equal to 12 log 2. Now we can solve this as log x is equal to log 2 raised to 4. How we got this? This log x remain as it is. This 3 get transferred here, that is divided by 3, and this get cancelled. This get cancelled, that will be 4 log 2, right? So I wrote the log x as it is, and log this 4 that we got after cancelling 3 and 12, that is 3 4s are 12. This 4 can be written here. So I wrote the same equation as log 2 raised to 4, right? We got this, and now we can write this as log 16. And the final answer for this will be 16. Since log and log gets cancelled, and the final answer for this will be x is equal to 16. Now let's go to the second last question. That is we have got, no, it's the last question. We have got log 2 to the base 10 is 0.30103, and we need to find the value of log 50 to the base 10. See, in this type of question, again, we need to find this. So we'll concentrate on writing this log 50 by base 10. So here what we need to focus is how can we write this 50 so that we can use this value that is given in the question. Okay, so I can write log 50 as, or I'll just write 50 as 100 by 2, right? So if I write log 100 by 2, it's again the same, log 50 by log 50 to the base 10. So it can be further written as log 100 to the base 10 minus log 2 to the base 10, right? Now log 10 to log 100 to the base 10, we know it's 2. How? If I need to solve this, then 10 raised to x is equal to 100, and of course it is clearly seen here that x is equal to 2, because this can be written as 2 times square, and since the base is equal, x is equal to. So I'll just write log 1 is equal to 0, log 10 is equal to 1, log 100 is equal to 2. So similarly, if it goes, it can be written as. So this is things that we can remember, and we don't need to compute each time. So straight away log 100 is 2, of course if the base is 10, minus log 2 to the base 10. Remember that we have got the value of log 2 to the base 10, 2 minus 0.30103, which will be final. The final value for this will be something around 1.6. It will be around 1.6989 something. This is the final answer.